Hello wonderful person, this is Anton, and today we're going to be discussing some really intriguing discoveries about ancient Earth. And specifically, we're going to be stepping back into the deep past, approximately 500 million years ago, when life on Earth was arguably at its most bizarre. We're going to be discussing what's known as the Ediacaran period, a transformative era approximately 635 to 541 million years ago, that eventually resulted in some of the most major transformations when it comes to the evolution of life and the formation of all complex life known to us. But specifically, we're going to be discussing some of the recent studies and the potential causes for all of this that may actually have a very bizarre and somewhat unusual geological origins. But I guess first, so what exactly was this era like? And what was Earth like back then? Well, here pretty much most of the life was still in the oceans. At this point, the ground itself was most likely barren, but the oceans were not bustling with fish and crustaceans, and instead was covered in life forms that barely resemble anything alive today. So all sorts of squashy fans, tubes, donuts, and flat discs, with many of them actually resembling plants, but still being creatures and animals like, for example, an enormous animal that grew up to about 4.6 feet long, or about 1.5 meters, potentially representing one of the largest specimens from this period, with some other organisms that we've discussed previously representing all sorts of creatures entirely different from anything today. For example, the unusual tiny slug-like creature Kimberella, that may have resembled something like this, was essentially one of the first complex animals that could potentially move across the seafloor and very likely graze on the seafloor. And for Earth, this was a huge achievement, because for the most part prior to this, all life was single-cellular or extremely primitive. And so here we had this bizarre explosion of complex multicellular life that today is referred to as the Ediacaran biota, a monumental leap in evolution. But the question here was always, why? Why now? Why not before? I mean, Earth had like billions of years to try this sometimes in the past, but for some reason it only happened approximately 600 million years ago. So what drove this bizarre sudden blossoming? And turns out the answer may lie several thousand kilometers below our feet, the liquid iron core. And so let's discuss the Earth's magnetic field, which as we know today is very likely formed by the churning motion of the molten iron in the outer core, and it's absolutely essential for making our planet habitable. And so the magnetosphere shields the atmosphere from dangerous solar radiation, solar winds, and cosmic rays. And if we hadn't had this early field on Earth, the solar winds would most likely strip pretty much everything from the surface, starting with most of the atmosphere and eventually water. But the thing is, based on a lot of geological evidence, we know that something really bizarre happened approximately 591 million years ago. Here the shield failed dramatically. Or to be more exact, it seems to have almost failed, and this particular period of extremely weakened magnetic field potentially lasted for several million years. And so quite a lot of new research that studied magnetism locked in ancient crystals revealed several major details about this time. Now in this case, a lot of these crystals are sort of like geological time capsules. They preserve the magnetic field record and even tell us how intense the field was during certain times. And that's because when these crystals form, they tend to solidify in a certain way depending on the strength of the field. And so here scientists discovered that for a period of about 26 million years, the Earth's magnetic field was profoundly weak. And while earlier evidence from the province of Quebec suggested that approximately 565 million years ago, the field was about 10 times weaker than today. We've actually briefly discussed this in some of the older videos. But in a lot of recent studies, something else was discovered. The latest geological evidence gathered from 591 million years ago, and specifically from ancient rocks in southern Brazil, discovered that the field was actually much weaker, up to 30 times weaker than today, or at least 3 times weaker than previously assumed. And this ultrafield intensity is the weakest known magnetic field in Earth's history. But there is something really interesting that happened around this time as well, because the failure of this Earth's essential protection system may have actually triggered the emergence of advanced life. But first, let's briefly discuss why we think this field almost failed. Now once again, the geodynamo is powered by the motion of molten iron in the outer core. And this is something that's been going on Earth for billions of years. And turns out that this process was getting more and more inefficient. And that's because Earth was actually cooling down, and as a result, the core inside was moving less and less. But unlike today, something else was very different about Earth back then. The innermost part of the core was actually entirely liquid, it seemed to have lacked the solid core. And so approximately 600 million years ago, by the Ediacaran period, at this point the entire system was basically running on its last legs. And so during this time the field started to fail. It was growing weaker and weaker, and even started showing signs of potential collapse. But fortunately for life on Earth, something changed deep inside the planet. And the answer to this enduring geological mystery seems to be directly tied to the formation of the solid core. Because as the planet cooled down, a lot of this molten iron started to transition from one phase to the other. And so around this time, researchers believe that the inner core began to crystallize, a process referred to as nucleation. And the moment this started happening, it surprisingly provided a really important energy boost. This transformation pushed the mechanism from the weak, unstable state into a very strong, stable magnetic field that we have today, because in this case, the solid inner core suddenly provided an important surface for the convection to become more efficient, and also added a lot of extra heat, which was suddenly released from inside. And so we now had this new sudden source for this continuous generation of geodynamo inside the planet. And so the recovery of the field strength seems to be directly associated with the growth of the inner core. And this was very likely also crucial for the prevention of the drying out of our water-rich, ocean-rich planet. But in this case, it was really timing. Timing was everything. The magnetic field was at its weakest right when the first complex life started to diversify. And as the field bounced back during the subsequent Cambrian period, this actually provided life with this new important magnetic field that now served as the shield for the next 600 million years. Although here I guess we have this new crucial hypothesis: a weak magnetic shield helped complex life evolve. And we do have some evidence about this as well, and it seems to be all related to oxygen. And so, for example, for some of the larger animals during this time, like those in the oceans during the Ediacaran period, in order to become successful and even in order to evolve, they did require a lot more oxygen. And traditionally, scientists thought that maybe this was provided by various cyanobacteria, or various photosynthetic organisms living in the oceans that would steadily produce oxygen over time. But in this case, the weak magnetic field offers us an alternative and also complementary explanation. And that's because the weaker magnetosphere provides less shielding from the solar wind, which actually allows a lot of lighter gases, especially hydrogen, to be lost to the atmosphere. We've actually seen this many times happening around Mars, even today. And when hydrogen is lost, more oxygen may remain in the atmosphere, instead of reacting with hydrogen to form water vapor. And so in this case, the ultra-weak magnetic field over those tens of millions of years very likely caused a sustained loss of hydrogen, which would then lead to increased oxygenation of the atmosphere and even the surface ocean. And so here the influx of oxygen might have been the key factor that suddenly allowed all of this somewhat complex life to start reaching new thresholds. And most importantly, it enabled more complex life to evolve, with even more complex bodies that would usually require a lot more oxygen. And so in this case, the weak field may have allowed oxygenation to cross a kind of a threshold, aiding animal evolution for millions of years. And so it's really around this time that we suddenly see sudden explosion of various types of animal life that today we often refer to as the Cambrian explosion. And so most of these bizarre animals that formed millions of years after were possibly the result of this extreme oxygenation following the Ediacaran anomaly. But the Ediacaran magnetic anomaly is not just about the weakness of the magnetic field, it's also about instability, because for years the geological record presented us with a major puzzle. Here a lot of paleomagnetic data seemed very chaotic, showing a lot of wild and conflicting variations in the magnetic field of the planet, which led some scientists to assume that maybe something really bizarre was happening inside the core, the mantle, and the crust, and maybe the entire magnetic field was wandering all over the place. But this recent study from 2025 provides us with some really precise and very detailed work that potentially explains this as well. And so here, by running a detailed analysis of volcanic rocks from certain regions in Morocco, they were able to precisely constrain the timing of these magnetic shifts. And what they found seems to confirm this true chaotic activity. In this case, the magnetic shifts seem to have happened in just thousands of years, as opposed to hundreds of thousands like in modern times. And more importantly, this did not involve any kind of a pole shift, but seemed to just involve extremely chaotic magnetic field during the entire period, with the field increasing and decreasing in strength extremely rapidly. And this might be the only such period in Earth's history at least according to the data and all of the evidence. And this also provides a lot of support for the hypothesis that the chaotic field preceded the solidification of the inner core. In other words, this potentially happened right before the solid core appeared and right before that crystallization period. With this study once again confirming that the magnetic anomaly seems to be directly linked to the crystallization of inner core, seems to have resulted in an extremely chaotic period, but most importantly, was directly correlated to the major evolutionary step in Earth's history. The evolution of a lot of bizarre complex life during the Ediacaran and the Cambrian periods, and the sudden appearance of complex animals in the ancient oceans. And so without that recovery, scientists believe that Earth might have looked extremely different today. Perhaps somewhat similar to Mars, or perhaps even similar to Venus. And even though these strange Ediacaran creatures eventually vanished during the Cambrian period, and even these Cambrian creatures eventually disappeared too, their brief existence, fueled by this extreme chaotic period on the planet, suggests that some of these major crises in the Earth's history, and especially planetary crises involving geology, can sometimes unlock biological potential on the entire planet and eventually result in super complex life. Which means that understanding a lot of these deep Earth processes is crucial for interpreting the planetary past, and also important for understanding how life may form somewhere else. So basically, just looking for planets in the habitable zone is not enough. We have to also consider the geological history of the planet, because in this case, the unsung hero of the story seems to be the Earth's core, and specifically the dramatic shifts at just the right time. But at least that's based on some of the recent studies that, as always, you can find in the description. We'll definitely come back and discuss this more once there are some additional discoveries. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon, where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. Alternatively, you can also buy the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.